go through number 8. We're going through number 8. Very, very nice one. Two lines have equations R, blah, 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 and the other R, whatever. Then they said, show that the lines are skew. So this is not a new word, all right? You learn about it in vectors, and we talked about it. Now I'm going to revise it with you as well. So you can see that in vectors, they like to ask you two very common questions. Number one is to find the angle between vectors, and the other one is to check if the lines intersect, or they are skew, or they are parallel. Okay, so in vectors, right, when we are representing lines, lines could either, you know, this thing that you have been given, the vector equations, you actually may have a question that can ask you to develop vector equations. We'll see one. Okay, we'll cross the bridge when we get there. We'll talk about it. But anyway, let me draw these lines. I'm going to show you when you have a 3D shape, for example. And then here's your nice 3D shape. It's a box, some form of a box. Now, if I look at line number, let's call this line number 1. And we come and we talk about line number 3. These two lines will never ever meet. They will never cross, and they are not parallel. Okay, because if they were parallel, then they would have the same gradient. They'll be the same lines, something like this. Okay, two parallel lines. These ones also don't meet. Now, line 1 and 3 are what we call skew. Okay, skew means that they are not parallel and they don't meet. Then these two will be saying these two lines are parallel. Then we are going to have the third situation where we are going to say that the lines actually intersect. We can have lines that meet at some point, and we'll be saying these two lines intersect. So lines can either intersect, or two lines will be parallel, which means they won't intersect. So they won't intersect, but only because they are parallel, or you can have them not intersecting because they are skew. Okay, which means that they face different directions, they would never meet. So when lines do not intersect, they could either be parallel or skew. So they want you to prove that lines are skew, like line 1 and 3. Okay, they are not parallel and they don't intersect. So they don't intersect and they are not parallel as well. So those are two skew lines. So let's show that. Now we can show that nice and easy, and we're showing it right now. And they want us to show it having given us two vector equations that are representing pairs of lines. Okay, because when we have vector equations, we can actually quickly check if lines do intersect or not, and check if they are parallel or not. Now, when the order in which we check is, we first check if the lines are parallel or not. Okay, then we are going to check if the lines intersect or not. Okay, good. So here we are going to check. When we're checking the lines, you should know that this thing tells us the location at which a vector intersects a line, and then this tells us the direction. So look, we are actually focusing on this first, the second part of your vector, which tells us the direction. So this is the part where we check when we are checking for checking if two lines are parallel. So what you're going to do is you're going to take a number, and you'd say, for example, -1 divided by 2. So I'm going to say, okay, what is -1 divided by 2? And I'm saying, is this going to be the same as -2 divided by 3? You're going to see that this is not the same. So you can say -1 divided by 2 is not the same as now saying -2 divided by 3. And this is not the same as saying 1 divided by -1, okay? So this just goes to show that you can say which is not the same. It is also not the same as 1 divided by -1. So you can say, therefore, the two lines are not parallel. In other words, there is no number. Because if they were parallel, you would have the same. You would have them equate and go down to be the same thing, because that will be just telling you that there is a number which you can multiply one of the directions, let's say this one, to go get the second one. If there was such a number, then we'd say the two lines are parallel. Okay? Then we'd say the two lines are parallel. So these two lines are not parallel. Okay? Why? Because there is no point, or there is no value that you would multiply one to get the other. All right, to get the other. Then multiply one direction to get the other one. Okay, so this one is fine. Now we've seen that they are not parallel. Let's now check if they intersect or not. How easy is that? What are you going to do now? For you to check whether they intersect, you use the whole thing, okay? So you're going to put the equations again. What are they? R is equal to -1. So you'd say, okay, R will be equal to -1. Then what? Then 3, then -4. -1, then 3, then -4. Like this. Plus, this is your R. Plus what? Lambda 2, 3 minus 1. Plus lambda 2, 3 minus 1. Okay? And you have the other R. You have the other R, which is going to be equal to, I should put an equal sign, obviously. I did. You should have another R now, which is equal to, like we should put it at the middle. You can see that. 2, -3, -1 plus mu. And this mu is -1, -2, -1. So it's -1, -2, and 1. Okay? Okay, no problem. Are we sure? Yes, this is the one. Now we should have left some space and say this is X, this is Y, this is Z. Here is our X, here is our Y, and here is our Z. Okay? You could have said X, Y, Z, right? X, Y, Z is equal to this. So let me go do this. So we can say X, Y, Z will be equal to this. If we could have put it, we could have removed the R and said X, Y, Z. Okay? X, Y, Z in brackets is equal to this. This other R is X, Y, Z. So we can say X, Y, Z is equal to this. We can remove R and put X, Y, Z. Like this. This is important. Right? Now we are checking if the two lines do intersect or not. So instead of calling them R's, we can call them X, Y, Z. Now we are going to say, okay, let's start by working with the X coordinates. Okay? Let's start by working with the X coordinates. You're going to have what? For the X, -1. So it's going to be -1. Then plus lambda times 2 becomes plus 2 lambda. Okay, -1 plus 2 lambda. This is going to be equal to, what is the other X for this other one? It is going to be 2, okay, this 2. Then you have plus mu times -1. So it becomes minus mu, okay, because it's mu times -1, which is just a mu. This is going to be equation number 1. Then you have for Y. What is it for Y now? For Y, you're going to have 3 plus 3 lambda, okay, because 3 and then 3 lambda. This is equal to, you now have -3. This is equal to -3, then -2 times mu, it will be -2 mu. Okay? Then now we go for Z. How is this? I hope you're understanding. We go for Z now. What is Z going to say? We have -4, then we are going to have lambda times -1. It will be minus lambda. This is equal to, we have -1, then mu times 1, it will be plus mu. So we have these 3 equations. Are you seeing the 3 equations? Now what we are going to do is we can use 2 to find mu and lambda. So you can say using 1 and 3. We can use equation 1 and equation 3. You can say equation 1, you can say X minus Z. What would this be now? If I say X minus Z, the whole thing, I would say -1 plus 2 mu. This is equal to 2 minus mu, right? Okay, so now let's say X plus Z, because I want the mu's to cancel. So I have a minus mu and a plus mu. I'm going to add them. So I'll say plus now, the whole Z, which is -4 minus lambda. Okay, -4 minus lambda being equal to -1 plus mu. Right. Now what am I going to get here? I'll just say -1 plus -4. It's like -1 minus 4. This becomes -5. You can put it in the calculator. Then 2 plus negative lambda. This is just going to be lambda. So, and it's a positive one. This is going to be equal to 2 plus -1 is like 2 minus 1, which is a 1. Minus mu plus mu, whatever, is going to be 0. So I have lambda, -5 plus lambda being equal to this. I have my lambda being equal to 1 plus 5, which means my lambda is equal to 6. Can you see that? Okay, I found my lambda as 6. Now I'm going to put them in the same version, in X plus Z. I'm going to use, let's say X, the equation for X, I'll say -1 plus 2 lambda is equal to 2 minus mu. Okay? This is equal to 2 minus mu. Then I'll say, let 6 be equal to the lambda. I'll now have -1 plus 2 by 6 is equal to 2 minus mu. Then I'm actually going to now have, let's reduce it. We always have to do it, right? Let's make some space. make some space. Let me make some space. So we have something like this now. Let's simplify 2 minus mu. Now this becomes minus 1 plus 12 is equal to 2 minus mu. Now we take mu to this other side and all the numbers will now have mu is equal to 2. Then minus 1 comes here, it becomes plus 1. Then 12 becomes minus 12. We have all mu being equal to 2 plus 1 is 3 minus 12. That's negative 9. You can put in the calculator. So I have lambda 6 mu negative 9. Okay, can you see it? Now what am I going to do with these two? What am I going to do? Lambda 6 mu negative 9. I'm going to go and try them in equation y. So trying lambda equal to 6 and mu equal to negative 9 in y. What are we going to have now? For y, 3 plus lambda is equal to minus 3 minus 2 mu. So 3 plus lambda is equal to minus 3 minus 2 mu. Now we are going to feed the values which we got. So we'll say 3 plus 6 is equal to minus 3 minus 2 by negative 9. Am I going to get the answer? Same answer. This is 9. Is it equal to minus 3? Minus 2 times this becomes positive 18 minus 3. That's 15. 9 is not equal to 15. So I can say 9 is equal to not equal to 15. So therefore, lines do not intersect. The lines do not intersect. So they are not parallel. The two lines are not parallel. The two lines do not intersect. So you can say, therefore, the two lines are skew. Okay, the two lines are skew. Because what you do is, you've seen what you do for the last part. You'll be having how many simultaneous, you'll be having how many equations? The x, the y, and the z one. And you're going to use any two first to find the lambda and the mu. Now when you have lambda and mu, you go and put it into the other one which you had left, and it should come out as the same. Don't put it where you have used. If you are using x and z to find them, then you have to come and put it in y and see if it's working. Okay, that is what happens, and you'll be seeing whatever. So here you have proved that the lines are skew. In the next video, we're going to now check how to find the angles between vectors, and we'll go on. All right, bye for now.